Hello everyone, welcome to our channel. In this video we are going to talk about the most economic circular section. Here we have drawn a circular section which its center is located at the O and it is partially filled with the water. So from this bottom of the channel up to the partial fulfilled, it is denoted by Y, which is the depth of the flow. In case of circular channel running partially full, both the weighted perimeter and weighted area vary with depth of flow. The most efficient section is designed both for condition of maximum mean velocity and maximum discharge. So as per the figure, here theta equals angle AOC, that is AOC, and angle equals COB, and the radius of the circle is R, that is this is the radius. Equals R, and depth of the flow equals Y, and the perimeter of this can be, that is weighted perimeter can be given as 2 pi r is divided by 2 pi 2 theta. This can be simply twice of theta r. This is theta, this one is r, and the weighted area is equals to of the circle can be given as area of OACBO minus area of OABO equals pi r square is divided by 2 pi times of 2 theta minus half of AB times of OD. Or this can be theta r square minus half of 2r sine theta times of r cos theta. Two theta is divided by 2. Simply this equals to r square times of theta minus sine 2 theta is divided by 2. These are the basic parameters. So after this we'll go to the condition. The condition are for the maximum velocity and the maximum discharge. In first case we'll go to the maximum velocity condition. In this we'll go by using d. A is divided P is divided d theta equals 0. D theta times of A dP is divided by d theta is divided by P square equals 0, or P dA is divided by d theta minus A dP is divided by d theta equals 0, or P times of r square 1 minus cos 2 theta is divided by 2 times of 2 minus A times of 2r equals 0. As we have already calculated the value of P equals 2r theta times of r square times of 1 minus cos 2 theta minus r square theta minus sine 2 theta is divided by 2 times of 2r equals 0. 2r cube theta times of 1 minus cos 2 theta minus Therefore 10 to theta equals 2 theta. So on solving this by heat and trial method, that is 2 theta equals 257.5 degree, and the value of theta will be 128.75 degree. After all this, we'll calculate the depth of flow. Now the depth of flow equals y equals r minus r cos theta equals r times of 1 minus cos, value of theta is 128.75 degree equals, solving this with the result will be 1.62 r, that is y equals 1.62 r equals 0.81 d, as d equals twice of r. And after this we'll calculate the hydraulic radius. A by P equals, the value of A was already calculated as r square times of twice of r theta is the value of P. So on solving this, r 2 theta times of theta minus sine 2 theta is divided by 2 times of so on solving the result will be 0.6086 of r, as theta equals 128.75 times of pi c is divided 180 degree equals 2.247. This value is used over this. This theta equals this is the calculation, and this value is used at this place instead of this. So for these two, the hydraulic radius r equals 0.305 d, as d equals twice of r. Now we'll go to the case 2, that is finding the maximum discharge. We'll use d times of a cube by 3 is divided d theta equals 0. Or P dot 3a. Placing the value on this equation, that is, this can be formed as 3 times of 2 r theta r square times of 1 minus cos 2 theta minus r square times of theta minus sine 2 theta is divided by 2. 2r equals 0. So on simplifying this, we'll get the theta equals 308 degree and theta equals 154 degree. After this, we'll calculate the depth of flow. Y equals value of theta is 154 degree equals 1.89 R, and the Y equals 0.95 D in terms of diameter. After the depth, we will calculate hydraulic radius. R equals A by P. The formula for hydraulic radius is A by P, and placing the value and simplifying this, placing the value, that is R is divided 2 times of 2.6. The value of hydraulic radius is 0.573 R. Now in terms of D, it will be 0.29 of D. This theta can be calculated as theta equals 154 times of pi c is 180 equals 2.687. So for this time we end up the video up to this much. We'll come again with one new video. Till then, keep on watching our channel and don't forget to subscribe us. Thank you.